Yeah, so as all of you know, we have been developing Laddy, the engine actually for lattice individualization as part within the Twikit customization platform. And for that, we like to work with partners such as BASF for unit cell development. So let me pass the word now to Florian of BASF, who we're collaborating very heavily with on the topic of unit cells.
Thank you, Olivier. Thank you for having me here today. And yes, I want to give you a short introduction into our lattice work we are doing with Ultrasim 3D, especially take you a little bit on the history and the journey when we started with lattices. And this was 2 or 3 years ago. And you have to take a look. We just started measured all kind of lattices, all with a certain weight, and ended up with so many curves. We were even surprised that we can get out of one material a whole bunch of this kind of different properties. And that was the reason where we said, okay, we have to find a way to make this easier accessible, get away on how customer can use it, but also us internally design right parts with our lattice designs. And we decided we have to make it digitally. And BASF has a long history in simulation, which means we were thinking, can we enable our lattice by simulation? And we started to develop material models, especially for the flexible materials. And you see it here, we did a testing, and now we developed material model, which has elasticity, Mullins effect, cyclic behavior. So everything you need for lattices, which is quite complex in the general FEA world. And as you see on the right side, our design and lattice match really well. So you see a simulation to experimental, and we can at different strain rates, different stress levels, several cycles, we can predict how a lattice will behave. But this is complicated, long time of work. We did it with customers to enable like helmets, back protectors, but how could we make it that everybody can use it? And we automated this workflow more and more. So we go from a parametric design to an automated workflow, which comes up with then something like what you see here, a landscape of properties. So we can see, for example, the force it's needed to press the lattice, depending on diameter and height, and find really the one, let's say, property, diameter, height, aspect ratio, which fits perfectly for an application. And we use this internally now for several years to optimize lattices, give it to a customer he's making a part. But now we want to automate this, get more into customers this access. And this is the reason why we on the one side clustered lattices. So to give you an idea, for different kind of applications, you need a different type of lattice, which gives you a different force over displacement behavior, either really linear with a high rebound, maybe something which is more like the cube-like structure for energy absorption, where you need a huge area under the curve, which is normally the energy absorbed by the part. And with those different lattices, we were able, again, easier to give a customer a first right choice on the lattices and only tune further parameters. And even there, we said, okay, how can we make this more easier? Because customer come and said, we developed a lattice, but now it's not printable. You cannot depowder it, all kind of struggles. And we started to say, okay, now we want to scale it down to certified lattices. And we had this lattice test bed where you go from quite small cell sizes to bigger ones, change in diameter. And we say, within this range of lattices, it's working. You can depowder it. It has certain properties. We know how they behave, and you can design your application. And who wants to look deeper and not only have to touch and feel, he can go into our library and really scan and say, I need this density. I need this shore hardness. I need a certain stiffness or compression hardness. Filter by a lattice, and then choose it. And of course, make a full design. And here we even team up now with Twikit, that those kind of designs are easily automated for the customer with several clicks going in full automation. And with that, I want to ask Olivier, I'm really curious to see, because I didn't have seen this. How did you do this and how did you make it?
Thanks a lot, Florian, for this explanation. Okay, so let me go into a bit more details of Laddy. Well, first the end slide of Florian, of course. And to start with Laddy, I'm going to actually zoom out. We're going to talk about what Twikit is all about. Twikit is all about customization. We really believe that there's a better way to bring products to market, and that is individualized, digital, and digitally produced on demand. And for that, we have developed an entire customization platform containing softwares to enable end-to-end workflows for design automation in those mass customization applications. Of course, for that, we need scalable cloud deployments. We need an open API-driven architecture so that we can easily integrate and connect with third-party solutions. And we have a web-based interactive 3D visualization that we use for our end customer customizers, which are accessible on the web. Okay, this platform enables through, what's the word? I forgot. Well, in any case, it means that on the customer side, we can actually cater as much customizer that we want, because adding a new customizer somewhere or enabling a new person to get to those customizers does not need you to install anything. You just go to a URL on an iPad and you're up and running for the customization process. We capture the parameters over there, and our Twikit platform caters it and produces the production files automatically, which we hand over to the distributed manufacturing networks on the back end, where we actually have a global reach so that you can really go for local production. And of course, if we're talking about lattices, then we also need individualization over there. And that key software component there was completely missing. There was no solution in the market where you could offer individualized lattices, and especially not if you want to offer web-based visualization for that. Laddy enables that. Both lattice individualization with guaranteed mechanical properties, as well as interactive 3D web visualization of completely lattified products. Okay, so like I already said, the key functionalities of Laddy are the fact that you can infill any shape that you want with static or dynamic infills. And of course, thanks to our partnership with partners like BASF, we can provide you with unit cells which are being validated, but you also have the opportunity to put in your proprietary unit cells. So full flexibility over there, because Laddy is a completely open platform. Like I already mentioned beforehand, really a key differentiator is the fact that we offer full 3D visualization in the front end to enable a full automated design automation flow. As any component of Twikit, Laddy is completely API based, so that we offer a full open solution. Okay, talking about the Laddy engine, it completely bridges the gap between engineering and commercial rollouts. Why? First, you start with the interface where you can input the meshes which has to be lattified. You define the entire blueprint of the lattices which you want to put in, boundary conditions, which kind of unit cells, so cube unit cells or ventile unit cells or anything, or partner validated unit cells. And the moment that all of this is being validated by your engineering team, it's just one push of a button for complete deployment online. Then that deployment enables that we automatically generate the customizers which can be integrated within your website, so that you have a 3D browser-based visualization in your web configurators to actually offer a full design automation flow. So let me run you one last time through the workflow actually about laddifying a product. Everything starts within your CAD system. So you design within any CAD system that you want the actual 3D files that you need. You input them into the Laddy interface, of which you can see live demos over here at the booth, where you start defining the blueprint, selecting which kind of unit cells that you want, boundary conditions, everything. Second phase about it, it's actually making sure that your front end looks the way it looks. So setting up your scene, materials, all of that. Then you have to actually make sure that the design automation fulfillment flow is also known. So this means setting up all the API connections in the front end, API connections in the back end. And then if you deploy, everything runs immediately on the web and you can have it integrated with your website. Voila. like Florian already said, if you want to have a look at the full working interface of Laddy, where you can easily use the unit cells of BASF, come to us. We will gladly give you a demo of the software. And that's it, actually. So thank you, Florian, for dropping by and presenting the entire history of the BASF unit cells. And yeah, I will now give you a demo.